So this is a problem that came up the other day when I was tutoring a student, and I had a mild brain fart and couldn't think of it. And we did the rest of the problem set, and then all of a sudden the time was up, and I had another student coming. So I promised to make a recording showing how to do this type of problem. Now that my brain's on straight, I think that it wasn't fully caffeinated. I can do this. Now, uh, these types of problems come up in systems of equation units, usually in math textbooks. Also, distance equals rate times time winds up being something used. So we'll talk about all that, but let's first just read the problem. We have a problem set here. We're going to specifically look at number one. Number one here says Selby walked for a while at 4 miles per hour and then jogged the rest of the way at 8 miles per hour. If she covered 56 miles in 10 hours, how far did she walk? How far did she jog? So let's draw a picture. I like pictures. Okay. So we're going to walk a total distance of 56 miles. Well, walk and jog, right? So that's the thing. We've got this total distance that she went and total time that she went, 56 miles in 10 hours. But she did some of the distance, so we'll write lowercase d instead of capital D, which we're going to have that equal total and total hours, lowercase d, and just to really emphasize the distance she went walking, this is what we need to find. And distance equals rate times time, but we're going to have two different rates because she was walking at a certain rate and she was going for a certain amount of time walking. So this is the formula for distance equals rate times time, and I'm putting a sub W to talk about walking. And we also have a distance that she jogged, and there's a rate that she jogged at and a time frame that she jogged. So we're really doing these two formulas. We also have the main, right? Distance equals rate times time, but this is total. We could put a T here, right? But here's our picture that we're going. And I don't know how far she went walking. I don't know how far she went jogging. That's what we have to find out. So each one of these distances, not necessarily drawn to scale, right? And what else they give you? Well, they give you her walking rate. We know her rate of walking was 4 miles per hour. We're also given her jogging rate of 8 miles per hour. So we've got all this information. We've got 1, 2, 3, 4, 5, 6 different variables, right? D sub W is not the same as D sub J. Same with the rates, same with the times. So how are we going to solve this? Well, we wind up having to put things together and say, well, I do know my walking rate. So let's simplify that and say that the distance she walked was the walking rate, the 4 miles per hour. We'll drop the units and bring them back later, times the time she spent walking. And likewise, the distance jogging was the rate that she jogged for the amount of time that she jogged. So now we've simplified this a little bit, but we still have 1, 2, 3, 4 unknowns. And what are we going to do? Well, we do know that she went 56 miles. And this 56 miles is represented by this line here, which is the sum of these two distances here. In other words, distance she walked plus the distance she jogged has to equal our total distance, right? Well, that means I can add these two equations together. I can add distance walked, rate times time, distance jogged, rate times time, and adding these two together, that's our total distance, and our total distance is 56 miles. So I know that 56 miles is 4 times the time that she walked plus 8 times the time that she jogged. Wow, now I got one equation and two unknowns. If only I could have some information that would relate the times. Well, that comes back to our total here. We related the distances by adding them together and getting total distance. I can do the same thing with the time. So if I add these two times together, time walked plus time jogged, that has to add up to 10. And I could either use elimination or substitution. Remember when I said this usually comes, this type of a problem is assigned in a systems of equations, and then they teach you to use substitution or elimination. You can use either one for this problem. That looks pretty good for substitution. I'm going to do that. Doesn't matter either way. I can solve for the time she spent walking, not in absolute terms, but as it relates to the time she spent jogging. I can subtract T sub j from both sides. And that means the time she spent walking was 10 minus however long she spent jogging. And now that I've solved for T sub w, I can substitute it into this equation. See, I've got two equations, equation 1, equation 2, and two unknowns. I can solve this sucker. So let's bring this down. Give us a little bit more room. Here's our total amount, the sheet, distance traveled, 4 times T sub w, but T sub w equals 10 minus the time she spent jogging. So that's our TW, right? We've just substituted. And I'm going to add the 8 times the amount of time she spent jogging. And now I've just got one variable. Make certain that you don't forget to distribute this 4 to the 10 and to the negative T sub j. That's 4 times 10 is 40 minus 4 times the time she spent jogging plus 8 times the time she spent jogging. And now, wow, I can combine these together and get 8 minus 4 is 4. I can subtract 40 from both sides. So 4 times the time she spent jogging equals 16. I can divide both sides by 16, and that means the time, and now I can put in units, time she spent jogging, 4 hours. And since these two have to sum up to 10, I can subtract 4 from 10 and get the time she spent walking. 6 hours. And now that I know how long she spent doing each activity, I was given her rates for both. The rates for both are up here. 4 times T sub w. Well, T sub w is 6. She spent 6 hours walking. So 4 times 6, we'll put it over here. 4 times 6 is 24 miles. That's how far she walked. And then 8 times 4, right? 8 times 4, she spent 4 hours. That's 32 miles. It should all check out. 32 plus 24 is 56. That's how many miles she went. So 24 miles walking, 32 miles jogging. We'll put an answer down here. 24 miles walking and 32 miles jogging. I hope this jogs your memory on how to set up problems of this nature in the future. Draw diagrams, write down any important equations you might need, write down as much information as they give you in the problem, and then just slowly, methodically figure out what you've been given and how you can ultimately write 2 equations with 2 unknowns so that you can solve. Thanks for watching.